Hey everybody, welcome to our lesson on the Isosceles triangle theorem. When you hear the term isosceles referring to a triangle, you will want to remember that that is a type of triangle that has two equal sides and the third is not equal to those other two. So the theorem says if two sides of a triangle are congruent, the angles opposite them are also congruent. I'm going to show you what that means. An angle opposite of a side is just simply the angle across from it. So if you go from your side of your triangle, draw an arrow down to the angle here, that would be the angle opposite of the side up here. So we'll do the same thing on the other side that has a mark. This is the angle opposite to this side. So since I know that these marked sides are congruent, these angles also have to be congruent. And that can help you find some missing parts in your triangles. You also need to know that if an altitude is drawn in a triangle, that's this thing here, it's going to split up that triangle into two congruent triangles, two equal triangles. And also the altitude bisects the vertex from which it came and the base. So it's sort of splitting exactly in half the vertex here that it's stemming from and the base length. So a couple good things to know when you're trying to find those missing pieces. Alright, so let's look at triangle ABC in this example, and the problem here is telling me that it is an isosceles triangle with side AB congruent to side AC. So notice they didn't give me those tick marks to show me which sides were congruent, but they are listing them out using their letters. So find side AB, this one here, and side AC, and I know those are the ones that are congruent, so I'll just put my own little marks there. And remember by the isosceles triangle theorem that we also know these opposite angles to these sides are congruent. If angle B is 62 degrees, they want us to find all the other angles in the triangle. We can do that. To find angle C, that's going to be easy because we know that has to be the same measure as B. So we already know that C is 62 degrees. And now think about what all three angles in a triangle, in the interior of a triangle, must add up to. And we know that's 180 degrees, 180 degrees. So we need to figure out the missing degrees measure. So we've got 62 degrees, another 62 degrees. So what's missing so that all of these will add up to 180? So go to your calculator with me. 62, another 62 has a sum of 124, subtract that from 180, and the missing degree measure is 56 degrees. So I found A to be 56 degrees, and they had already given me B, 62. So we did what we were asked. We found the missing other angles. Alright, triangle ABC in this picture is an isosceles triangle again with angle B congruent to angle C. So let's go mark those. Those are congruent. Find the length of side AC. Alright, so we're going to have to rely on what we know about this theorem. If B and C are congruent, that means side AC and side AB are congruent. Once again, as in our other picture, those are congruent. Knowing that, even though I don't have any straightforward measures on these sides, I can set something up here. If I know those sides are congruent, then these expressions are congruent. So I'm just going to write that out. Write out what you know. 4x plus 7 is supposed to be equal to 7x minus 8. Well, now I have an equation that I can solve for this missing variable x, and that might help me find my answer. So let's do that. So to solve for a variable, remember we're going to try to get it by itself, isolate the variable. So we need to move things using opposite operations until we have done that. So right now I'm going to move over this 4x term to the right hand side here by subtracting it. And I'm going to rewrite what I have. 7x minus 4x is going to be 3x. Okay, I need to now move away my negative 8, or my minus 8, so I'm going to add 8, the opposite. Alright, working towards getting that x by itself. 15 equals 3x. That's going to add up to 0 there, so I'm going to mark that out. And I still don't have x totally by itself, but I can get it to be isolated by dividing away that 3, both sides. So now I have x equals, I'm going to do 15 divided by 3, and that'll give me 5. But look at the question. Find the length of side AC. Have we answered the question yet? No, we found the value for x, but what are we going to have to do to find that length? Well, you can see that the expression on side AC is 7x minus 8. So we're going to go take that value we found, we're going to substitute it in for x right here. So the rule says I need to multiply 7 by my x value and then subtract 8. So 7 times 5 minus 8. So we've got 35 minus 8. So we should end with a value of 27. Now we've answered the question. The length of side AC is 27 units, or whatever units they have it labeled in. And this concludes our lesson on the isosceles triangle theorem.